Kuku, welcome into this video. In this video, I would like to take you through how you can conduct descriptive statistics using SPSS. So in order to start this illustration, we need to load data in SPSS. And in order to load data, I would recommend we use the same dataset, which is a pre-installed dataset with SPSS, which is an example dataset, that is, which have been pre-installed with SPSS. So in order to locate that dataset, you need to head to your File Explorer, then come to where we have local disk C, then get to where we have program file, then get to where we have IBM, then SPSS, then statistics, then 27, then come to where we have sample, then select the language as English. Then I need us to use this demo file which is here. So there are various demo files, but I would recommend we use this one for uniformity. So let us load it into SPSS. So let us give it time. So let us give it some seconds to be loaded. So after loading this dataset, now you can notice that we can be able to view the data and the variables and the different variables making this dataset. So before we start conducting our descriptive statistics, we need to have an overview of what is descriptive statistics. So first thing first, in descriptive statistics, we usually apply two measurements. So the first measure is the measure of the central tendency, which includes the mean, the median, and the mode. And then we usually conduct a measure of dispersion, where we have the variance, the standard deviation, the maximum and the minimum, and then the range and the standard error. But where we conduct a test of the standard deviation, there is no need to do variance. And where we do maximum and minimum, we don't have any need to conduct a descriptive statistic of the range. That is because technically standard deviation is the square root of the variance, and then the range is the difference between the maximum and the minimum value. So there is no need to be repetitive. So in order to do descriptive statistics, we usually have two methods to do it when we click analyze. So the first method is the frequency method, and the other is the descriptive method. So, but I show you how we usually do it. But first thing first, before you start doing any analysis in SPSS, it's usually advisable you first check if you are experiencing some missing values. So in order to check if you have any missing values, what you need to do, you need to select analyze, then come to where we have missing value analysis. Then you need to move this total dataset in the quantitative variable. And in order to move this total dataset in the quantitative variable box, you can either click use all the variables, or just come here, click control all, and then use this arrow to take all the data in the quantitative variable box. But because we are having some categorical variables, so we just select use all the variables, and now the categorical variable will be input where we have categorical variables, and other quantitative variables will be put in the quantitative variable box. You don't need to select any pattern, you just need to click OK. So we need to counter check if we have any missing value. Then from there, after doing that, you have these univariate statistics, which is basically universal statistics, where what we need to focus with is where we have the missing value. So you can notice we have count and percentage. So according to statistics, any missing value, missing value over the total sample, which is technically above, or the percentage of missing value which is above the set threshold of 5%, is technically regarded as harmful. But any missing value as per the total observation, which is below 5%, is not harmful for our analysis. So as you can notice here in our dataset, we don't have a lot of missing values, which tell us this is quite a good dataset to carry out analysis. But where we had internet, we had a missing value with a count of 255, which is below 5%, which is the set threshold, which is because it is 4%. So this one is not harmful to our reporting and into our descriptive statistics. So our data is good and it is clear to do any analysis. So always remember it is a commandment to counter check if your data set contains a missing value. We have a very big data set which is 6,400 sample. This is a very big data set which can contain some missing value, which can result to absurd reporting. So you need to counter check this first before now we start our analysis. So first thing first, we can get back to our data set. So we need to get to our first analysis where we shall be using the descriptives. So in order to use the descriptives, we need to select analyze. Then we need to come to where we have descriptive statistics. Then we need to come to where we have descriptives. Let me show you. The computer is honey. So we need to come to where we have descriptives. Then we need to select the variables which we need to conduct the analysis for. So I need some continuous variable and then a categorical variable which can help us to do a clear analysis. So we shall first use the age of our respondent, which is a continuous variable, which the measure which we usually use is the scale measure. Then we have the marital status, which is a categorical variable. So it is a categorical variable since it includes a category. So there is a category which can be of married people and there another category of unmarried people. Then we need to select the household income. So the household income is a continuous variable since it is scale in nature and it is continuous since it follows a continuous distribution. Then from there, we need now to click options in order to select the descriptive which we need to measure. So we need to measure the mean. We don't need the sum. Then for dispersion, we need to use the default which have been provided by the software. So you can notice where we have clicked the standard deviation, we don't need the variance since the standard deviation is the square root of the variance, or in case we have the standard deviation and we need to get the variance, we need technically to square the standard deviation. It have also ticked the minimum and the maximum. We have avoided the range since in order to get the range is the difference between the maximum and the minimum. So there is no need of overpopulating our output. Then we don't have the standard error since it is also a repetition. So from there, what we need to include, even when we are measuring the descriptive statistics, we can measure the distribution of our data and see in case we have a variability of certain outliers which affect our data set. So we need to click the kurtosis and the skewness and then click OK. Then we can learn our data, but you can learn by syntax by just clicking paste. But for this case, start by learning about how we can use syntax. That is, I demonstrated in the end of this video how we can use that syntax to learn this data set, but we need to click OK. So a tabular or a tabulant table will be generated here, which contains these descriptive statistics. So the first variable is the age, the second variable is the marital status, and the third variable is household income, which is here. So what we need to do, we need to check the minimum value of our age. So you can see this is how we interpret this data. The minimum value of our age or the minimum statistics was 18 years, or the maximum statistics of our age was 77 years. So that was the distribution of our data set. Then the mean statistics of our age. So where the mean statistics was like the average age of this data set was 42 years. Which is 42.06 to be specific. Then the spread of the data was 0.29 years. So that is the spread of the data or dispersion of the data from the mean. Then the skewness. So our data seems to be symmetry or to be symmetrical since the skewness of our data is close to 0, which is technically the accepted skewness of the data or our data to be normally distributed. But when we get to where we have the frequency, we will generate a normal curve and see how the distribution occur or how the normal curve is skewed and see the skewness. So is around the mean, which is the normal distribution since it is close to 0, which is the mean is the skewness is close to 0, which is close to 0.0299. Then we can check the kurtosis. So the kurtosis is the tailness of our distribution of our normal distribution curve, which is around negative 0.602, which is also close to 0. So that means that our data is close to be symmetrical or normally distributed. Then when we come to the marital status, which is a categorical variable, that's why I wanted to deal with it. So the minimum and the maximum of the categorical variable does not inform us much about the data set. Also, the mean statistic of this information is not too important to us. What is too important to us in this data set is the skewness, or how the marital status or the distribution of marital status is, the curve is distributed. So it seems to follow a normal distribution, since the skewness is close to symmetry, which is 0.015. Also, the kurtosis it seems to be negatively tail. The tail seems to be protruded to the negative side, which is negative 2.00. Then we come to our other continuous variable, which is the household income. So it seems, since the income is in thousand, here this is where I'm checking. It seems that most of our respondent, the minimum income ranged from 9,000, or the maximum income ranged from 1,100,016. Then the mean of their income was around 69,000. I'm avoiding the decimal point, which is 69.47.78 thousand. Then the dispersion of this income from the mean was around 78.71856 thousand, which is technically showing that we had a good dispersion from the mean. Then this data seems to be skewed to the right. We had a lot of outliers to the right side, which is around 4.513, which is not close to symmetry. So this data must be skewed to the right. Then the kurtosis, the tailness, is close to 33.877, which is also the tailness. So the tail is too protruded to the right. So you'll be able to visualize this clearly using the normal distribution curve or the distribution curve. It will help us to visualize this effect. So this is how we usually do descriptive statistics using SPSS. So I want us to use the second method now, using the same variables without adjusting anything. So you can see the varied number of the observation, the total number of observation, removing the ambiguity. It is 6,400, and as you can see, and we don't have missing values. So what I said, you must consider the missing values, since sometimes they can result you to make some absurd reporting. So from there, we need to get to the analyze again, and then come to where we have analyze, then come to where we have descriptive statistics, and then we choose frequency. So we need to take the variable which we want to conduct the descriptive test for. So first variable was our age. Then the other one was the categorical variable, which is marital status. Then we have another variable here, which is income. Was it income category? We needed to use the, not income category. Yeah, income category in thousand. Okay, so it is good. Income category in thousand, and it seemed to be a nominal variable. So I wanted the continuous variable of income, the current household income, not income category. So I needed the household income, which is here, which is a scale variable. Then when we put this value under the frequency variable table, as I showed you how we move this variable, I'm forgetting to show you. I have back in mind that all of you have interacted with this software, but assuming you have never interacted with this software, in order to move this variable age into the variable box, just click above the variable age and bring it here. Then select the household income and bring it here. But we have different methods which we can be able to move this variable into the variable box, but I usually recommend the arrow method. But you can also click above the variable which you want to move here, like marital status. You can double click it and it will move in the variable box. Then in order to conduct the statistics, just click where you have statistics. Then what we need to select, now this one answers the other central tendency measures. So we have the mean, the median, and the mode. So we shall just click the mean, the median, and the mode, which are the central tendency measurement. Then we now deal with the quantiles and percentiles. So we do with measures of dispersion. But in case you want to deal with quartile and cut points, you can, however, put the comment in the description and be in the comment section and be able to deal with them. Then we will measure the measures of dispersion, and then we will deal with the standard deviation. We will not deal with the variance, since they are one and the same thing. Then we will deal with the minimum, maximum. Then for the distribution, we will deal with the skewness and kurtosis, and then we will click continue. Then we will we'll come here and we can try and select charts. So we choose a histogram for each of the variable which you are conducting the analysis for. Then select show normal curve on histogram. Since we want to see the skewedness of our data set, then we can click continue. Then we can learn the data. So display frequency table. So I don't need to display frequency table to make our data precise. So this is our descriptive statistics which have been conducted now using the frequency method. So as you can notice, the difference between the frequency method and the descriptive method, let me show you something. The difference technically, it is technically the display of the table or the tabular or the format which the output is being produced. So as you can see, the table, which is the tabular, which is giving us the frequency, is different from that. Using frequencies is different from that of descriptives. So as you can see, the statistics here, all of them, they are the same. As you can see, the mean of the age is 64. The median of the age is around 41. So as you know, the median is the middle value after arranging the data in a systematic order, let me say that, or in a chronological order. Then the mode is the variable which continuously seems to occur or with the highest frequency. Then the dispersion is the spread away from the mean, how our data disperse away from the mean. Then the skewness, we say the skewness is how our data is being distributed as per the age. You can notice it's all the same as I explained in the same table. The minimum age is 18 and the maximum age is 77. Where we come to the income, we have the number of the varied sample as 64,000. We have zero missing value. The mean of income in 1,000 is 69.4778, which is around 69,000. While the median is around 45,000 and the mode is around 25,000. And now these ones should inform you something, that this data is not technically normally distributed due to the difference between you can notice some level of dispersion or some level of difference between the mean, the median, and the mode. So when you come here where we have the skewness, you can notice the data is not close to zero, is far away from zero. So that data is not close to symmetry. Then you can notice our kurtosis, also the tail is too prolonged to the right, as you can notice. And also where we come to the marital status, as you can see, where we have kurtosis, the tail must be prolonged to the left, the left hand side. And then you can notice that the data according to the skewness is technically skewed to the normal distribution or to the symmetry. The maximum and the maximum in the marital status, since it is a categorical variable, does not make a lot of sense as per now. Then, as you can see, we can be able to, when we generate our histogram, as you can see, it's technically about the age. It seems to be skewed to, if you observe properly, you can see that this data is not technically normally distributed. It seems to be skewed somehow. Kidogo to a very small margin to the right, as you can see. You can notice our skewness was close to 0.299, but it seems to be normally distributed, as you can see. Then, as you can notice about the kurtosis, which is the tail, let me show you. Let us get back to the table. I want to get back to the frequency table, which is here. I demonstrate to you something. So as you can notice, when it comes to the age, we notice that our kurtosis or the tail is somehow, we have a somewhere where we don't have a lot of data set where it is here. This is where the kurtosis represent. So we had a tail which is prolonged to the left in the negative side. As you can see, so this is how we interpret it. Then you can notice, I want to see the household income. As you can see, the data is skewed to the right, to the positive side. So this data is not normally distributed. And you can notice the kurtosis, which is represent where the data is tailed, where we don't have any other data set which it is representing. We have a kurtosis which is close to, it was close to -2 as a measure, or the measure which we had conducted. Then you can scroll downward and come to where we have marital status. So marital status is technically perfectly, or it's normally distributed. As you can see, we are experiencing a normal distribution curve where we have marital status, and that is how we usually learn descriptive statistics in SPSS. So in order to learn these descriptive statistics, and we want to save it, since we will be using this dataset to carry out a lot of our analysis when doing this course. So I would like to show you how you can use syntax file and save some syntax file which you can save as an output, which can help you to learn this project later in case you had a data which you are carrying out an extensive project that is. What you're supposed to do, maybe you want to do a descriptive statistics, or first of all, we started by checking some missing values. So you can come to where we have missing value and record every activity which we did using syntax and see the command which the program ran. So maybe it's the missing value. You come here, what we did, you can remember we used all the variable, we took all the variable in the quantitative variable box and the categorical box. So what you need, instead of clicking OK, you need to click paste. And when you click paste, a command will be generated. Then in order to get the output now, you need to click this play button or learn selection, and you can see the univariate statistics output have been played using the syntax file. Then you can come back again. Let me get back again into the syntax. Then we can click analyze. Then we can come to where we have descriptive statistics under the syntax file. Then we can select descriptives. Then we can learn the descriptive statistics which we had and then paste it here. Then we can click run. And when we click run, you can notice that the descriptive statistics will be produced to us using the syntax method. So the syntax helps us to save this dataset easily, and when it comes to reference, it will make our work very easy. So we shall save this syntax file for later reference when continuing this project or this class. Then we need to do the descriptives using the frequency method. So I just come to where we have analyze, then come to where we have descriptive statistics, then choose frequency. So we shall just use the variable which we use. Then instead of clicking OK, you click paste. And then you can notice the command which we have run, it will be produced here. This is the command which we ran in order to get this output from this software. So I just click here and you can be able, and the same output will be given to us. Let me click run. So let me come back again and hit run. So you can notice our data is being produced. It is here. It is here. Every data which we had used the wrong method. So I want to save this syntax file. So, and I will save this syntax file for later reference. So I just click file. Then I'll just click save. Then I'll save this syntax file as descriptive statistics. Descriptives. I want to save it as descriptives. Let me just save it as descriptive, which is descriptive lesson 5 SPSS. So this is how I save this syntax file, and when I need it for reference, I'll be able to get it, and I can repeat this procedure by just hitting play. And when I hit play, everything which I did, it will be printed, and I can be able to run this command very easily, and can help me to quickly access the different command which I had played when doing my project. So basically, thank you for watching. Please don't forget to give the video a thumb up and also to hit the subscribe button in case you get this tutorial helpful. Also, you can be getting our tutorial in our channel in case you want to learn more about how to use SPSS. So technically, thank you for watching, and may God bless you. So before I forget, before you do any analysis in SPSS, please remember to watch lesson 004, which I'll be demonstrating to you how you can, which I have already done it for now, which will be showing you how you deal with missing value, which is a problem when doing a lot of data